are both wings attached to the airplane. Is the nose there? Is the tail there? The, quote, four corners. You have to take what wreckage you have and reassemble it so that you can then begin to understand the forces that were actually on the airplane at impact in its last moments of flight.
Investigators used the same technique to uncover why TWA-800 crashed off New York in 1996, killing 230 people. Analysis revealed that the plane exploded in midair. Then pieces of debris drifted slowly down to the water with little further damage. Terrorism was initially suspected, but the cause was later identified as faulty wiring that triggered a fuel explosion. Structural engineer Jim Wildey was part of that investigation. Now he faces a jigsaw with most of the pieces missing.
In this case, there's only a limited amount of structure that's recovered. It fortunately does tell enough of a story to at least give a clue as to what's going on with the airplane.
Two of Flight 447's four corners have been recovered: the tail fin and nose cone. Wildey starts with the nose.
If this piece was to come off the airplane and float to the water by itself, it wouldn't be going fast enough so that when it hit the water, it would be damaged really in any way.
Flight 447's nose cone is severely deformed.
What we see here is that this piece has been flattened, it's been crushed, it's been torn, and so this is a very clear sign that this piece was on the airplane when the airplane hit the water.
The nose did not drift down slowly from the sky. The tail fin tells the same story. A mid-air breakup couldn't create the type of damage seen here. And a recovered floor section from the cargo compartment adds another piece of the puzzle.
And what we see here is curvature damage on both sides of this piece with a fracture down the middle. This damage is consistent with the airplane hitting relatively flat and with very high hydraulic pressure coming up from below and deforming this piece in the manner that's shown here.
Analysis of the wreckage is clear. When Flight 447 hit the water, it was level and in one piece.
Whatever the cause of the accident is, it better take into account the fact that this airplane is hitting the water relatively flat at a high rate of speed.
Wildey's conclusion: Flight 447 didn't explode in midair. It fell out of the sky. But why? The aircraft is an A330, built by aerospace giant Airbus. Though there are 700 in service, there hadn't been a single passenger fatality until Flight 447. This history of reliability rests on a highly computerized flight control system.
They're highly automated. They're some of the leading edge technology in aviation even today.
Powerful computer systems are designed to control everything from airspeed and altitude to turning the aircraft. The design philosophy that automation improves safety. In a flight simulator,
V1, rotate.
Veteran pilot Martin Alder demonstrates the features of these computer systems.
Gear up. In a conventional airplane, instead of this side stick, I'd have quite a big control column here, but you need plenty of leverage to apply the mechanical forces you need to move the control surfaces to control the airplane.
In a conventional airplane, the pilot pulls mechanical levers to operate a hydraulic control system. But on the A330, this heavyweight gear is replaced by an electronic system called fly-by-wire. The pilot tells the flight computer what he wants to do, But it is the computer that translates this intention into action and executes the maneuver.
So if I want to go to the left, stick to the left. Round to the left.
The flight computer adjusts the control surfaces and the aircraft turns left. Maneuvers like this cause the A330 to lose altitude. So the advanced computer compensates by increasing power and pitching the nose up to provide the right amount of lift. The pilot does nothing.
I take my hands off, and there we are. It's flying round. Vertical speed 0, 25 degrees of bank, 240 knots. It's going to fly around at 25 degrees of bank, keep doing this until we get bored.
The flight computer won't carry out any pilot command that endangers the safety of the aircraft.
If the pilot were to lose control for some reason, the system would save the airplane.
With this safety feature, it seems almost inconceivable that the crash of Flight 447 was simply due to pilot error. So did something in Flight 447's path bring it down? Cable hunts for clues buried in over 400 pages of data released by the French authorities and finds one crucial fact.
There was thunderstorm activity in that area, quite a large trail across the flight path at the time that AF 447 went through.
At 2:10 a.m., Flight 447 is in the vicinity of an Atlantic thunderstorm, 250 miles wide. Did it cause the crash? To find out, our investigation turns to John Williams, an aviation weather specialist at the National Center for Atmospheric Research in Boulder, Colorado. Williams has access to new satellite images taken by NASA on the actual night of the crash. They show a massive storm developing as Flight 447 approaches.
I'll step through by 30-minute intervals, and you'll see these storm systems starting to grow.
The final position of Flight 447 is marked on the top of the map.
This storm system is hundreds of miles across and maybe 60 miles wide. Wow, look at the size of that growth right there.
Pilots are trained to avoid large storms like this.
The idea that a pilot would fly through a thunderstorm, absolutely not.
Pilots, remember, at the front end of the airplane, the first people to meet any accident. We have a great incentive not to meet accidents.
So why is Flight 447 flying straight into the storm? In daylight, the thunderclouds would span the horizon, towering from the ocean to 50,000 feet. But at night, the pilots can't see them, so they use onboard weather radar. This radar has a limited range of around 50 miles, and it can't see wind or lightning. It works by detecting the water and ice in storm clouds, but ice is 5 times less reflective than water, and pilots must continually adjust radar settings to see storms of different size and intensity.